Okay, part 2 of the video for the little motor generator thing. So we've got a 4-wire bridge rectifier, 5-wire, there's not much different except for the center taps are joined. 6-wire one, center taps aren't joined, and they're all the same setup with the 8 diodes. So I'm going to try this setup and this setup probably. First we'll try it without the join between the two center taps, and then we'll go to this. So I sort of have one made up. I've got it attached to that. I got me 8 lots of diodes. They're joined through there to there, and over there and down to there. And the coil, one coil is connected to that point, and the other one there, and the other one there, and there. And I have a massive cap. It's probably overkill. It's 200 volt DC cap. But that'll do for now. At least we can't blow it up if it's too high voltage. So this should suit both of the little stepper motors, this plug. That was out of the first one. These 2 wires are our center taps of each of the coil. So I'll go connect that up and see what happens. 34 volts DC. Damn it. Wires connected, hang on. Vibration. Those 2 connected. Okay, we've got 35 volts DC. I have a little motor here which is on the side there. And 12 volts and 12 amps. That's out of the battery drill. That's the amp meter, I'll just connect it. Oops, we're doing milliamps installed. Need more idling I think. Hang on, I'll start it up again. That motor to run. Connected to that one. We're doing 300 milliamps and 33.9 volts DC. And I'll get back. Center tap connected. We're still at 33 and 200 milliamps now. So that seems to work. Vibrating like I don't know what. And the tune. The battery. Pretty easy. Connecting this larger one up and see what our results are on that one. So I'll set that up and I'll get back. The cap's holding 32 volts. I'll short it out and see what happens. It should drop. Can we get the milliamps in? There we go. Didn't have much in there really. Not the same plug end. Similar, but not quite. It won't fit. Another day maybe for that one. I'll get back. Here, these two here, red and that little white with a red strip, are 4.2. The green and white one and the green are 4.2. And when it's connected, these two aren't no resistance, but that one and or that one 3 point something. Well, I'm connected up so you get the exact reading. Okay, 3.3 ohms on that wire. So I'd imagine these are like a center tap, but not quite. Not sure really. They have no power, no resistance to each other, I think. Yep. No resistance. So I'll use these two on one end of the diode bridge rectifier, and those other two here, and we'll see what we get. Okay, back with the slightly larger stepper motor. No load. 33 volts. Just connect the load. Got a load on, only 140 milliamps, no voltage. It's quite actually warm compared to the other one, and it's only been running for a second or two. This one had less resistance. It was only like 4 ohms maximum. That one there was in the 10 ohms. That one delivered more power. This one's lower on power and voltage. So the size of the motor, not much important. It matters about the windings. Alright, I'll find another motor to connect and see what happens. We might try that one. Okay, it's got brushes, but a DC output. 7 volts of load. There's the load, running 140 milliamps of load. 120, 130. Look out, look how that's spinning up. Beauty of having a clamp as your generator stand. Well, that was quite powerful for a bit of extra revs. Not bad. Needs probably a pulley on there. A larger pulley here perhaps, but I don't know about that setup yet. I got some other little motors, so that one's pretty high in milliamps, low in voltage at the moment because due to the revs. Interesting. Alright, I'll continue. This treadmill seems to be a bit weighty. I can't start the whippersnipper motor with this attached. Just doing it like this is pulling out nearly 250 milliamps and voltage. Two to 3, just at that speed. It's probably a good candidate for a generator motor, but you need a bit more horsepower, I think. As soon as I attach this belt, I can't start the whippersnipper at all, even with it loose. I think the flywheel's got too much weight on it for the veneer. I'll try again later, but I'm knackered from pull starting the bastard. Need electric start now. I can't use this one. It's a 24 volt DC. It's got brushes. It's got some big magnets in there. I was hoping this part would be just attached with those two bolts. Turns out it's part of the whole housing. To take the gearbox out, you're still left with this flange and you can't get to the spindle. You'd have to chop through here. But it's pretty torqued up. I just wound it by hand and got like 250 milliamps. Very slowly because that's really geared up. So what it does to your hand. Oh well, put it back in the shed. Just the whippersnipper playing up, I think. Bit of strain on it. You can hear a bit of strain on the motor. I think I just have to line this up a bit better. It's doable, I think. We'll try it out. I found another pulley, a bit larger than the one I was using before, which is good. That's all set up sort of pretty true, sort of. The bolt sort of a bit sloppy in there. I've just used some copper shims to take up the slack inside the housing. This motor, it's got too much weight for the piston. It sort of spins, but it stalls the motor due to this spinning so fast and generating more torque here than the piston can actually put out, so it stalls the motor. So I have to put that away. Okay, checking out this little compressor I found ages ago. It's got a pretty strong magnet in it, and the wires are cut anyway, so I'll have to come into the casing. But for the piston, I wasn't expecting this. Check it out. Seems to be a bit of some sort of rubber around there for the seal. That's it. So we might be able to just undo these. There's a circlip there, and see if I got some pulley or something what will fit on this. And let's see what they did here. I'll need two hands, I think. Whatever they did, they cut the wires. Alright, I'll get back. It's got a relay here, I think. Looks like a switch. And we got these two little red wires coming out of the housing, plus the main power inlet. But I don't know where that one was attached, or this little red one. Comes off of that relay. It says it's DC 12 volt 40 amp. So I've got it connected on the positive and negative. I'll give a little bit of a turn like this, so we're not going that fast. We're about half a volt. We'll put it on 200 milliamps. Oh, that's pretty beefy. 150 just like this. See? Wow, but I don't think I've got a pulley for this end or anything to attach it to because there's not much there. Got a flat spot here. Don't think I can use the bits that come off. And where's the little weight? Oh, I've lost it. Surprisingly, you put things down. Ah, here it is. That's just like a half moon piece set into that little sprocket. It takes the camber. That was a bit hard to get off actually. And this here is that bolt there was that tight. It's like it's threaded inside. I'll see what I got. Probably nothing. Might just run the belt straight off of that, even though it's got a flat spot. It might bounce a bit. But we can get an idea of what it's worth. I presume it's DC coming out because it's brushed. I'm pretty sure it's brushed. I don't know if I want to pull it apart. They're hard to get back together sometimes. But if we do, I'll get back. It smiles on me today. Washing machine motor. And it's got this. I'll unscrew those fins because I tried this. It was like 4 volts without exciting anything, adding power to it and no amps. And this thing fits on there pretty easy, I think. Let's have a look. Put it backwards. Not too shabby. Alright, I'll bolt this on and see what we get. That was easy. Okay, bit up, belt's a bit loose. Not lined up that well. 16 volts. I'll try a load. Okay, so the little rough setup. 16 volts, 16. 100. Motor fell off. Okay, that was interesting. Besides it rattling apart on me, I think I'll choose that motor if it still works being down there. On the last test we just did, and then it stopped producing voltage, so this is feeding the coil some power, I'd imagine. I'm guessing. I'll try that again when I hook up the motor again and pull that wire off and see if we can draw any load out of it. If it is actually brushed, I should check that out. Okay, back in action. I've touched it back to its little base plate. So we've got our load on. the clamps going. Vibrations and G-clamps, or quick action clamps, do not go together. Yeah. Alright, I'm kind of happy with that motor. That's actually pretty good. One more test. I'll pull that lead off of that thing and see if we can get any voltage out of it without this switch relay thing on it. Okay, we got voltage, and that's about that. Clamp on this time. So it starts up under load as well, so that's a good thing. Yeah, so that little compressor motor has been rebirthed to a generator motor, and that's how loose the belt is, so it's probably slipping a bit. Slips on that main one there pretty easy. So I'll might rig up a frame sometime when I get some time and make myself that little generator. I think I'll pull this apart and have a look inside. I reckon the bolts are just there. The back end will pop off and we can see in there. So it is a brush motor. Down in there you can see the brushes. They're connected to those fatter leads, and I know what the switch does now. It's a thermal cut-off switch. There's a thermal couple. So obviously when it gets too hot, the switch is activated and turned off. So we probably can just snip all that stuff off and have the two black wires hanging out, and don't worry about the thermal coupling. Now I got to get those brushes back in there. They're not worn out, but they've popped out of their socket, which I didn't really want to do. But I'll get it back in there and set it up. Sometimes curiosity is not a good thing. That was very hard to put back together. Managed to get it though. The shaft wasn't turning before, but now it's alright. Had to sort of line up that pin. And there's not much thread on these things. Very poorly constructed motor, probably cheaply manufactured, but it's back together and it's working. I think I'll disconnect that wire and give it a run, see if we can actually run it without this. We might need this, the capacitor maybe, not sure on that. Doesn't need that stuff on the end. I'll put a capacitor. 15 to 16 volts, and the capacitor gets rid of the AC, filtering it. So now we have a good DC motor. I don't know what's negative. Spinning backwards. I'm going to stop that. Okay, so it's probably spinning backwards, so I'm going to have to swap these leads over. Now we have AC and go back the other way. Back to the drawing board. Okay, without the capacitor, no AC, after that. day I might make a frame for it. So if you ever find a DC compressor laying around, pick it up. And if you find a little whippersnipper motor, take that too. So thanks for watching, and maybe in the future I'll make a box for it.